Number one is a Le Chatelier's question. For A, so when we're trying to do colors, the trick I think is to first decide which way the reaction shifts, left or right, and then match it up with the color. Anything that shifts to the right is going to be brown, and we're going to see a brown color change as more NO is formed because we're told NO is brown. Anything that shifts to the left is going to be clear. So for A, NH3 is removed. If we take away NH3, we're going to have to shift left to replace it. So that will give us a clear color change. For B, water is added. Notice that the water is liquid. Since it's a liquid, we're going to have no change. I'm going to go ahead and erase part of this so that C can have some room to work. Temperature is decreased. Whether the temperature causes temperature changes, which direction they shift, depends on the sign of the delta H. This reaction is endothermic in the forward direction, meaning heat is absorbed, or I can view heat as being a reactant. If temperature is decreased, I'm removing heat, taking away some of that, and we're going to shift left to replace it, using up some of the brown stuff, resulting in a clear color change. For pressure and volume, we're looking at moles of gas. So make sure not to count the water. On the left-hand side here, we have 9 moles of gas. On the right-hand side, only the NO is gas, so we have 4 moles of gas. Pressure is decreased, makes the container bigger, more room, more stuff. It's going to shift towards the side with more moles of gas, giving us a left change, which is clear. Volume is decreased. For volume decreasing, I'm making the container smaller, so I want to have fewer moles of gas. So this is going to shift right, which we will see as a brown color change. If a catalyst is added, it'll reach equilibrium more quickly, but we'll have no change in the equilibrium position. Adding a noble gas won't bind to anything, won't take anything away. It's also going to give us no change.